This is Michael Hilton. We're going to do a sample calculation for Lab 2. My videos seem to be uploading a little bit blurry, so I've written it in darker ink. Hopefully that helps. Okay, so this is the data table that we were to fill out. This is the acid that I picked for our sample calculation, hydrochloric. This is the pH, and we need to solve for all of these. We were given the pKa, which is -7. So to figure out the hydrogen concentration, we're going to take the inverse log of the pH. Okay, so we just plug that in, one right here, and that gives us the hydrogen concentration. To solve for the hydroxide ion concentration, we take K sub W, which is 1 times 10 to the -14 divided by the hydrogen ion concentration, and so we just plug in the numbers here, and this gives us our hydroxide ion concentration. For Ka, we're going to take the inverse log of pKa, which we were given right here. So all we do is we plug that in here. Those negatives are going to cancel out and make a positive, and we're going to get 1 times 10 to the 7th for Ka. That's the Ka value. For Kb, we're going to take K sub W, which remember is 1 times 10 to the -14, and we're going to divide it by the Ka value that we just figured out. So it's a pretty simple calculation right here. 1 times 10 to the -14 divided by 1 times 10 to the 7th. That's going to give us 1 times 10 to the -21st. -21, I guess. Alright, so the last one we need to find is pKb, and all that is through a little algebraic rearranging of the equation. We're going to take 14 minus pKa. That gives us 14 plus 7 because of the two negatives here. That's going to give us 21. And so we just fill in the data table. We did that on the lab. And this is Michael Hilton for sample calculation, Lab 2.